Now that we've worked our way through how to name all of the different tissues, I want to take a moment to put the entire dichotomous key together in one place. We always start by finding cells. We typically do that by looking for the dark staining nucleus and then trying to find the light coloration of the plasma membrane that goes around that. Once we found cells, we ask, do those cells pack closely together? If no, they don't, we ask a follow-up question of, are those cells neurons? If yes, they are neurons, we're looking at nervous tissue. If, on the other hand, they are not neurons, we're probably looking at connective tissue. If we think we're looking at connective tissue, we name connective tissue by the way its extracellular matrix looks, so our follow-up questions that are special for connective tissue ask about that extracellular matrix. How much white space do we see? Is it loose or dense or cartilage? Once we've done that, we then ask about the fibers. What shape are they, or are they even apparent on the image in the first place? If we go back to, do the cells pack closely together, and instead we say, yes, they do, that leads us in a different direction on our decision tree to two other possible categories. So we need some kind of question that helps us tell the difference between them. That question is, do the cells and their nuclei line up in relatively straight rows or lines? If yes, they do, we're probably looking at some kind of epithelial tissue. Once we think we're looking at epithelial tissue, we have new special follow-up questions that we only ask for epithelial tissues, like the number of rows that we see. Is it a simple type of epithelia, or is it stratified? Once we've answered that question, we then ask, what shape are the cells? Are they squamous, cuboid, or columnar shapes? If we ask, do these cells that pack closely together line up in rows, and we say no, well, that tells us we're probably looking at a muscular tissue. Once we've determined that, we ask different follow-up questions that are unique to the muscular tissues. The first one is, do we see striations, a tiger stripe kind of appearance? If no, we don't, we're probably looking at smooth muscle. If yes, we do, then we need a question that helps us tell the difference between skeletal muscle and cardiac. That question is, are the cells straight in shape, or do they branch and go off in different directions? If they're straight shaped cells, we're looking at skeletal muscle, and if they're branched shaped cells, we're looking at cardiac muscle. I'd also like to give a couple of suggestions. First is to remember there are three things that you need to know for the tissue practical. One is you need to be able to name a tissue just by looking at it using our dichotomous key. Two is you need to be able to describe at least one specific location where that tissue can be found. And by specific, I mean don't just name an organ. Organs are groups of tissues, so what part of that organ is made of that type of tissue? For example, we can find simple cuboid epithelia in the kidney tubules, but not just kidney itself. The kidney includes a number of other types of tissues. The third thing that you'll need to know is the ability to describe a function that tissue serves inside of the body. In addition to remembering that there are three things to know for this practical, I encourage you to practice, practice, practice. A couple of ways to do that is to use any flashcard materials that your instructor may have provided to you, and or to go out to Google Images and just type in the name of different tissues and look at different pictures of those tissues, keeping in mind not every image is going to look the exact same. But if you follow the steps of the dichotomous key, you should be able to name a tissue regardless of what that image looks like. Also keep in mind that the images on Google Images, well, they're not always labeled correctly because anybody can put those images up. So you want to make sure that you think that those tissues are properly named, again, using the dichotomous key. And with that, good luck.